Welcome to learning Python Web Penetration Testing by Christian Martorella. Video course by Pact Publishing. I am Paul Bailey, the voiceover artist for this course. Christian has been working in security testing for more than 10 years now. He is the author of multiple penetration testing tools, such as WFuzz, MetaGoogle, The Harvester, and WebSlayer. All of them included in Backtrack and Kali. He has presented security research in many conferences, like the OWASP Summits, OWASP London and Barcelona, Black Hat Arsenal, and OSIRA. He has also delivered penetration tests for Fortune 500 companies, utilities, banks and governments. In this course, we're going to learn the penetration testing process and see how to write our own tools for different web application penetration testing phases. This course will provide you with the skill set necessary for creating your own penetration testing tools and to modify existing security and hacking tools to suit your own purposes. You will leverage the simplicity of Python and available libraries to build your own web application security testing tools. The goal of this course is to show you how you can use Python to automate most of the web application penetration testing activities. Before starting to write our own tools, we need to first understand what is the penetration testing methodology and the different phases that need to be performed, which will be our focus in the first section. Also, in this section, we will introduce the testing environment created for this training, based on a virtual machine and a vulnerable web application. Then, we're going to review the HTTP protocol and the basics of HTTP requests and responses in section 2. Here, we're going to learn to communicate with web applications using Python and requests library, which will be the core foundation of our tools. In section 3, we're going to map the content of the application to understand how it is composed and to identify the entry points that we need to test. Also, we're going to see how to harvest data from the web application that can be used later in our tests. In order to do so, we're going to create a web crawler using the Python library Scrapy. We're also going to work on the www.pactpub.com website to map resources and harvest interesting information. Now we know how to map a web application using a crawler, but most of the applications have hidden resources. These resources are not accessible for all the users or are not linked at all. Luckily, we can use brute forcing technique to discover directories, files, or parameters in order to find vulnerabilities or interesting information to use further in our tests. In section 4, we're going to write a tool to perform brute force attacks in different parts of the HTTP requests, URL, headers, and body. We're going to use as a target the vulnerable web application created for this course. Now we are going to review the different approaches to password cracking, and we're going to write a tool to brute force different types of authentication, such as basic authentication, NTLM, and form-based. We're going to work against the vulnerable web application. In section 6, we're going to learn how to detect and exploit SQL injection vulnerabilities. Most modern applications interact with a database, and the majority is still using SQL language. If an application has a SQL injection vulnerability, it could allow attackers to bypass authentication, extract data, and even take control of the underlying OS. We are going to write a script to detect and exploit a simple SQLi to detect SQL injections. And then we're going to add data extraction functionalities, and finally, we're going to run OS commands through SQLi. One of the most important tools in web application testing is the HTTP proxy. This tool allows us to intercept the communications between a browser and the server, giving us the opportunity to manipulate the content of the request. This is very useful, as it allows us to access the raw HTTP request. In our final section, we are going to write plugins for MITM proxy in order to intercept, log, and modify HTTP requests. And finally, We're going to create a plugin that will let us test for SQL injection in every URL that has parameters. The only prerequisite for this course is to have basic programming or scripting experience, which will facilitate to understand the examples quickly. In terms of environment, you only need to download the virtual machine that contains the vulnerable target web application and the Python environment with all the libraries necessary. To run virtual machine, you will need to install VirtualBox from www.virtualbox.org. I hope you now have a complete grip of what's to come and you're as excited as I am. So then, let's get started on this wonderful journey. Hi, and welcome to the second video of Section 1, Introduction to Web Application Penetration Testing. In this section, we're going to present an overview of the course content, why it is important to perform penetration testing, learn about the web application testing methodology, the tools used by professional penetration testers, and finally, we will introduce our lab environment and the target testing application. Now we move on to the first video of this section. Here we will understand what the web application penetration testing is and the process behind it. In this video, we will start by learning what is web application penetration testing, the importance of performing these tests, how professional methodologies look like, and finally, we are going to briefly explain why it is important to have skills to use Python to write our own tools. Penetration testing is a type of security testing that evaluates the security of an application from the perspective of an attacker. It is an offensive exercise where you have to think like an attacker, understand the developers and the technology involved in order to unveil all the flaws. The goal is to identify all the flaws and demonstrate how they can be exploited by an attacker, and what will be the impact for our company. Finally, the report will provide solutions to fix the issues detected. It's a manual and dynamic test. Manual means that it heavily depends on the knowledge of the person doing the test, and that is why learning how to write your own penetration testing tools is important, and will give you an edge in your career. It is dynamic test, which means that we test the running application. It is not a static analysis of the source code. The security test is useful to validate and verify the effectiveness of the application security controls, and to identify the lacks of those security controls. So, why should we perform penetration testing? Nowadays, IT has taken the world by storm. Most of the company processes and data are handled by computers. This is the reason why companies need to invest in security testing, in order to validate the effectiveness of security controls, and many a times the lack of them. One report by EMC states that the average report annual financial loss per company is $497,000 for downtime, $860,273 for security breach, and $585,000 for data loss. Plus, all the time, the company resources are put into incident response and fixing, testing, deploying the issue. That is why performing penetration testing will help companies to protect their customers' data, intellectual property, and services. Penetration testing is a simple methodology formed by 4 main sections. First, we will start with the reconnaissance phase. In this phase, we are going to gather information to identify the technologies used, the infrastructure supporting the application, software configuration, load balancers, etc. This phase is also known as fingerprinting. Then, we move into the mapping phase, where we build a map or diagram of the application pages and functionalities. We aim to identify the components and their relationship. One of the techniques to support the mapping is the spidering or crawling. Also, in this phase, we are going to discover non-linked resources by performing brute force attacks. Once we have all the components, parameters, forms, functionalities mapped out, we move to phase 3, where we are going to start the vulnerability discovery. After identifying all the vulnerabilities, we can move to the last phase, which is the exploitation of the vulnerabilities. And depending on the scope of the pen test, once you exploit a vulnerability, you can start the process all over again from your new vantage point. Usually the target DMZ, which you will try to get into their internal network segment. One step that is not represented here is the reporting phase, where you document all the findings to present to your customer company. Finally, there are two types of penetration tests: the black box and the white box. Black box test takes place when you don't have any information about the target, basically the same situation as an attacker. And white box takes place when the customer provides us with documentation, source code, configurations to accelerate the process and focus in interesting areas only. You may be wondering, what areas should you test during this process? These are some of the most important ones to cover: configuration and deployment management testing, identity management testing, authentication testing, authorization testing, session management testing, input validation, testing error handling, cryptography, business logic testing, client-side testing. We are going to cover some of these areas in this training. I encourage you to expand your knowledge on these areas by reading the OWASP Testing Guide. So, why build your own tools? Web applications are very different, since they are developed using multiple technologies, combinations, flows and implementations. This is the reason why there is not a single tool that will cover all the scenarios that you will find during your career. Many times, we are going to write scripts to test specific issues, automate certain tasks, and to exploit a vulnerability. During this training, we are going to see how to write tools and test different areas like authentication, input validation, discovery, and we end up writing a simple HTTP proxy that could be the foundation of our own security scanner. Writing your own tools is a valuable skill that will put you ahead of many penetration testers that do not have the capability to adapt tools or write their own. And in certain penetration test engagements, this could make all the difference. In this video, we have seen what is a web application penetration testing, why it is important to perform the test, what is the methodology to follow when performing a penetration test, the different domains that need to be covered, and why it is important to know how to write your own tools with Python. In the next video, we're going to see what are the typical tools used by penetration testers. Some of these tools are HTTP proxies, brute forces, password crackers, vulnerability scanners, and many others. Hi, welcome to the third video of Section 1. In the previous video, we learned about penetration testing, the methodology of performing web application penetration tests, and the different areas of interest to look for when testing web applications. In this video, we're going to take a look at the different tools used by security professionals to perform web application penetration tests. We will cover HTTP proxies, crawlers and spiders, vulnerability scanners, brute forces, and some tools used for specific tasks. The most important tool for testing web applications is the HTTP proxy. This tool allows you to intercept all the communication between the browser and the server in both directions. These proxies are called man-in-the-middle proxies. These tools will let us understand how an application works, and most importantly, it will allow us to intercept the request, responses, and modify them. Usually, the proxy will run in the same machine as the browser you are using for testing the application. The most used HTTP proxies by security professionals are Burp Suite, from Portswigger Security, and Z-Attack Proxy, also known as ZAP. We also have MITM Proxy. It is a newer alternative, developed in Python, and good to build tools or automate certain scenarios. The downside is that it's only console and there is no GUI, which for our purposes is a benefit. Then we have crawlers and spiders. These tools are used for mapping web applications, automating the task of cataloging all the content and functionality. The tool automatically crawls the application by following all the links it finds, submitting forms, and analyzing the responses for new content, and repeating this process until it covers the whole application. There are standalone crawlers and spiders like Scrapy, written in Python, or command line tools like wget, httrack. And we have crawlers and spiders integrated with the proxies like burp and zap that will benefit from the content that has passed through the proxy to enrich knowledge about the app. One good example on why this is valuable, it is when the application is heavy on JavaScript. Traditional crawlers won't interpret JS, but the browsers will. So the proxy will see it and add it to the crawler catalog. We are going to see Scrapy in more detail later. Now, we step into more complex tools, the vulnerability scanners. These tools are considered more complex, as they have to automate most of the security testing methodology in one tool. They will do the crawling, discovery, vulnerability detection, and some of the exploitation. The two most used open-source web application security scanners are W3AF, written in Python, and Arcany, which is written in Ruby. There are multiple commercial alternatives, like Reconnaissance, which is one of the cheapest and provides good value for money. Web bruteforcers or discovery tools are used to find content like files, directories, servlets, or parameters through dictionary attack. These tools use word lists put together by security professionals during the last 10 years, containing known file names, directories, or just words found in different products or web applications. The precursor for these types of tools was DIRB, which is still available and maintained by Dark Raver. Another great alternative is WFuzz, which I developed in the past, and is now maintained and developed by Xavier Mendez. You can find this tool in Kali, the most used penetration testing distribution. Tools like burp and zap provide these capabilities. All these tools benefit from word lists, like the ones provided by FuzzDB, a database of word lists for web application testing. We are going to see how to build a tool for this purpose similar to WFuzz. Then, we have a vast array of tools that are focused to specific tasks, such as encoders and hashers, Base64, MD5, SHA1, and Unicode. Tools that are created to exploit a specific type of vulnerability, for example, SQL injectors like SQLmap, XSS consoles like Beef to demonstrate the impact of AXSS, DOM XSS scanners like Dominator, and many more. Also, an important type of tool in the toolkit are the post-exploitation tools. These tools are needed once you manage to exploit a vulnerability and help you to control the server, upload files, shells, proxy content to internal network, and help you expand your attack internally. There are many other tools to overcome the infinite challenges we find testing new applications and technologies. In this video, we have seen the tools that make the Web Application Pen Tester Toolkit. This will help us understand how the tools aligns with the methodology, and will also serve as inspiration when we need to create our own tools, learning from them and understanding how they work. In the next video, we're going to see how to set up the environment for this training, and the tools you'll need to install. In the previous video, we learned what are the tools that a professional penetration tester use when testing a web application. In this video, we're going to take a look at our testing lab environment. We will start by installing the VirtualBox software to run our lab VM. We are going to access the vulnerable web application, get familiar with the text editor, and finally, I will give you an important warning. The first tool that we need is VirtualBox. This will allow to run the lab environment virtual machine created for this training. You can download VirtualBox from virtualbox.org/wiki/downloads. Choose your host OS and download the installer. After downloading VirtualBox, we can download the virtual machine created for this course. Once the file is downloaded, we can proceed with the installation of VirtualBox. Install VirtualBox. In my case, double-click on the .dmg file. We follow the installation instructions and once we are finished, we decompress the lab virtual machine. In my case, I use an archive in OS X. You can use 7-zip in other platforms. Once decompressed, we will start VirtualBox. And we are going to open the VM. Once the VM is loaded in VirtualBox, we are going to start the machine. Wait for it to boot until we get the login prompt. We are going to log in with the user pact and the password secret. Now we have our lab ready for action. For the purpose of this course, we have created a vulnerable web application that will allow us to test for different types of vulnerabilities using our own developed tools. The application simulates a very simple banking application. It is developed in PHP with MySQL, and it is served by Apache. Now we are going to open the browser in our VM and load the URL scrapybank.com. I created a /etc/hosts entry to redirect that hostname to localhost. This application is running in an Apache server in the VM. You should see the index page. If you click in Learn More, we will see some information. And on the top right-hand side, you can access the login page. Our last tool in the lab is the text editor, where we are going to write the scripts. One possible choice would be Atom, a multi-platform, open source, and free editor developed by the GitHub folks. Feel free to install or use the editor you prefer. In order to start Atom, go to the desktop item named Atom, and the editor will start with a blank file. You can start typing code, but until you don't save the file and add an extension, it won't do syntax highlighting. I will open an example in my home directory called test1.py. This is how a Python script looks in Atom. Last but not least, I want to highlight that many of the penetration testing activities, if not all of them, are not allowed to be performed without the target company's permission. In many countries, these activities are illegal, again without proper permissions. Always use a testing environment whenever you want to try a new tool or technique. Again, whenever you're going to perform a penetration test for a customer, get a written authorization. In this video, we have seen the lab environment we are going to use throughout the training. We have installed VirtualBox, run the lab virtual machine, and we have accessed the testing web app, Scrapy Bank. We saw a quick example of the text editor, and finally, we have seen an important warning about the consequences of doing penetration testing without permission from the customer. In the next section, we're going to learn how to interact with a web application using Python, understand the anatomy of an HTTP request, URL, headers, message body, and we are going to create a script to perform a request, interpret the response and its headers. Hi, and welcome to Section 2, Interacting with Web Applications. In the previous section, we learnt about the web application security process and why it is important to test application security. In this section, we will see the basics of the HTTP protocol and how it works. Then, we will analyze an HTTP request to understand its parts. We will start using Python to interact with the web applications. And finally, we will analyze HTTP responses and explore the HTTP headers. Now we move on to the first video of this section, which deals with understanding the HTTP basics and how it works. In this video, we're going to learn about the HTTP protocol, how it works, the security aspects of it, and which methods are supported when performing a request. This will provide you with the basic knowledge about HTTP, which is important to understand how to build tools and test for security issues in web applications. HTTP stands for Hypertext Transfer Protocol, HTTP. It was designed to enable communications between clients and servers. The HTTP is a TCP/IP-based communication protocol, operating in the application layer. Normally, we use a web browser to interact with web applications, but in this training, we will leave the browser behind and we are going to use Python to talk with web applications. This protocol is media independent. This means that any type of data can be sent via HTTP, as long as the client and server know how to handle the data content. And it is stateless, which means that the HTTP server and the clients are aware of each other during the request transaction only. Due to this characteristic, neither the client or the server retain information between requests, which will later be helpful when you perform some attacks. HTTP protocol is available in two different versions. HTTP 1.0, which uses a new connection for each request-response transaction, and HTTP 1.1, where the connection can be used by one or more request-response transactions. HTTP is not a secure protocol, meaning that all communications are clear text, being susceptible to interception and tampering. Generally, HTTP is being served on port 80. This is an example of what a simple transaction looks like. On the left, we have the client, which sends an HTTP GET request to the server asking for the resource test.html. The server returns an HTTP response with a 200 OK code, some headers, and the content test.html if it exists on the server. If it does not exist, it will return a 404 not found response code. This represents the most basic GET requests in the web application world. In 1994, HTTPS was introduced to add security on top of HTTP. HTTPS is not a protocol itself, but the result of layering HTTP on top of SSL or TLS, secure socket layer, or transport layer security. HTTPS creates a secure channel over an insecure network. This ensures reasonable protection from eavesdroppers and man-in-the-middle attacks, provided that adequate cipher suites are used, and that the server certificate is verified and trusted. So, whenever the application handles sensitive information, it should use HTTPS. Banking payments, shopping websites, login pages, profile pages, etc. Basically, if we handle, process, or store customer data, it should use HTTPS. In HTTP, methods indicate the desired action to be performed on the chosen resource, also known as HTTP verbs. HTTP 1.0 defines three methods: head, get, and post. Head will only return the headers and the status code without its content. Get is the standard method used to retrieve resource content, given a URI. Post is the method used to submit content to the server, forms data, files, etc. Then, HTTP 1.1 introduced the following methods. Options provides the communication options for the target resource. Put request to store a resource identified by the given URI. Delete remove all representations of the target resource identified by the given URI. Trace. This method echoes the received request so that the client can see what changes or additions have been made by intermediate servers. Connect. Establish a tunnel to the server identified by a given URI, used by HTTPS. Patch. This method applies partial modifications to a resource. Head, get, options, and trace are, by convention, defined as safe, which means they are intended only for information retrieval and should not change the state of the server. On the other hand, methods such as post, put, delete, patch are intended for actions that may cause side effects either on the server or external side effects. There are more methods than these. I encourage you to explore them. In this video, we have seen that HTTP is a client-server protocol, which is stateless. This protocol doesn't provide any security, and thus is why HTTPS was created, to add a secure layer on top of HTTP. We also learned that there are some different methods that will instruct the server to perform different actions on the chosen resources. In the next video, we're going to dissect an HTTP request and response and understand its parts. In the previous video, we had a brief introduction of HTTP, and we saw a basic GET request example. We also saw the different HTTP methods available that we can use to interact with web applications. In this video, we're going to take a look at the structure of a URL, the request and response headers, and an example of GET requests using Telnet, to understand how it works at a low level. I bet you have seen thousands of URLs by now. It's now time to stop and think about the URL structure. Let's see what each part means. The first part is the protocol in web applications. The two protocols used are HTTP and HTTPS. When using HTTP, the port that will be used is 80. And when using HTTPS, the port will be 443. The next part is the host we want to contact. In red, we can see the resource or the file location in that server. In this example, the directory is content and the resource is section. Then we have the question mark symbol that indicates what's to come is the query string. These are the parameters that will be passed to the section of page for processing purposes. There are some alternatives, like adding username and password for authentication before the host, or explicitly defining the port for cases where the web server is not listening in the standard's 80 or 443 ports. Now, let's talk about headers. Headers are a core part of HTTP requests and responses. They describe how the client and the server talk to each other and also provide information about the transaction. We have client-side headers which are sent by the browser. Some examples are user agent. This informs the server what type of OS, browser, plugins the users have. Accept encoding defines which encoding the browser supports, usually gzip or deflate. This will compress the content and reduce the bandwidth time for transaction. Referrer contains the referrer URL, basically from which page you clicked that link. Cookie. If our browser has cookies for a site, it will add them in the cookie header. And we also have server-side headers, which are set by the web server. Cache control defines the directives which must be obeyed by all caching mechanisms along the chain. Location is used for redirections. Whenever there is a 301 or 302 response, the server must send this header. Set cookie. It is the header used to set a cookie in the user's browser. www authenticate. This header is used by the server to request authentication. When the browser sees this header, it will open a login window asking for the user name and password. This is an example of how a response header looks like when making a GET request to www.packedpub.com. Some of them we mentioned here, like cache control, content encoding, content type. I suggest you getting familiar with all of them, and every time you find a new header, read about it to learn its function. After reviewing the URL structure and the headers, let's try a GET request on a real server. In order to do so, I will use the terminal and telnet command to send a raw GET request to the server. This is us simulating a browser by typing in the telnet connection. Let's switch to our VM and open up the terminal and type telnet www.http://bin.org 80. 80 is the port we want telnet to connect. http://bin.org is a website that provides an HTTP request and response service, useful to test tools. Hit Enter. Once we connect, we see this message. Connected to http://bin.org. Escape character is chevron close square bracket. That means the connection is established. Next, let's type get /IP http:/1.0 and hit enter twice. This is us telling the server that we are using get to request the resource called /IP. And then we specify the http:/1.0 protocol followed by 2 enters. As a result, we get our first response from the server. Notice, we haven't used any headers at all in the request, but we received many headers from the server, plus the content of the resource IP. In this case, the content is the IP address of the machine making the request. Now, let's do another example, but this time requesting a URL that has a parameter. Telnet http://bin.org 80. Get /redirect-to URL equals http:// www.bing.com, http/1.0. Again, we used get, but this time we request the resource redirect to with the parameter URL in the query string with the value http://www.bing.com. In this case, the server basically redirects the browser to the URL provided, using the location header and returning a 302 redirection code. Here is the return code. And here is the location header. In this case, nothing happens, as Telnet doesn't interpret that header. Remember, this is a raw connection. In this video, we learned about the URL structure, the request and response headers, and performed some hands-on examples on how to perform a GET request using Telnet and raw HTTP commands. In the next video, we're going to start communicating with web apps using Python and the requests library. Hi, welcome to the third video of section 2. In the previous video, we learnt about HTTP requests. In this video, we're going to start to write Python code to perform HTTP requests using the requests library. First, we're going to do a quick introduction to requests library. Then, we're going to write our first script to perform a GET request. We're going to see how to access the response headers, perform a head request, and finally, how to perform a POST request using Python and requests library. Requests is an Apache 2 licensed HTTP library written in Python. It was created to reduce the complexity and work needed when using URL lib2 and other HTTP libraries available at the moment. On the left side, we can see an example of the code needed to perform a request to api.github.com using authentication when using URL lib2 library. On the right, we can see the same function but using requests library. The simplicity is pretty evident. It really facilitates our job when coding scripts. Let's start programming in Python. In this first example, we're going to perform a GET request using Python and requests library. Let's open the Atom editor in Virtual Machine and create a new file. We are going to import the requests library to start with. Now, we create a variable R where we're going to instantiate a requests object. With the method get and target URL in this case is http://bin.org/ip. Finally, we print the content of the response using r.text. Save the file in Examples Section 2 folder. As video3.py. Let's run it on the terminal. Open the terminal and change directory to Example Section 2. And we run it with Python video3.py. We can see the response body here. Where we can see again is my IP. Remember that /IP returns in the body the caller IP. That's it. That was our first script using request library. Congratulations! You are communicating with the web application using Python. Now, let's add a query string in the GET request. In order to do so, we're going to add a variable called payload with a dictionary where each key is the parameter name and the value will be the value of that parameter. In this case, the parameter is URL and the value will be http://www.edge-security.com. Then we are going to change the resource to /redirect-2 instead of IP. This resource is expecting a parameter URL with a valid URL, which is going to redirect us. We also need to add the payload as a value for params in the request. Params equals payload. We now save it. If we run the script, we will see the content of the redirected page in the terminal. Python video3.py. There you go. Here we have all the content of www.edge-security.com in the terminal. That is how we add parameters to the query string. What if we want to see the return code from the server? We need to add the following code. Let's print some title by typing print status code. Then we can print some formatting and to get the code r.status_code. We can remove the print r.text to obtain a cleaner response. We save it and let's run it in the terminal with Python and the name of the script. We can see as a result the status 200, meaning the request was valid. We are now going to see how to get access to the headers of the response. We go back to the editor in the virtual machine and we open the file video-3-header.py that is ready to save some typing. This script is using the resource /IP again. In order to access the response headers, we use the method headers of the request object. In order to print them line by line, we can do a loop and unpack the key and values from the r.headers:. Let's try and run it in the terminal. We Python and the script file name. You can see the different headers returned by the server, plus the response code, and the response body content. What if we want to request only the headers to save bandwidth and accelerate the REC response transaction times? We go back to the editor and we change the get method by the head method. We save the script. We move to the console and run it. We can see the status code being 200. And we are getting back the headers, but we don't have the response body content anymore. This is because the method used is head, and we only get the headers from the server. Now, we're going to see how to set the headers of a request. Why would we want to do that? Because we may need to add a custom headers expected by the application. We want to fake our user agent to trick the server into thinking that we are a mobile device. We may want to change the host header to trick the server or load balancers. Or we may want to brute force or tamper with a header value and see how the application handles it. Let's try to set a header. We go back to the script in the editor. We're going to modify the request, changing the method back to get, and the resource from IP to headers. This will make http://bin.org to send us back the client headers they receive in the body of the response for debugging purposes. We save it and we run it. We can see that the user agent that requests library sends with every request is python-requests. Now let's go back to the editor and let's set the user agent header to a random test value. We need to add a dictionary called myHeaders with a key name, user agent, and the test value iPhone 6. myHeaders equals open curly braces, apostrophe, user-agent apostrophe, colon, apostrophe, iPhone 6, apostrophe, close curly braces. We also need to add the request, a parameter called headers, with the value myHeaders. Let's run it again in the console. Great! We see that the server received our modified user agent, faking we are an iPhone 6. Fantastic! Now you know how to manipulate headers. Now that we saw a GET and a HEAD request, let's do a POST request, where we're going to send the form parameters. Go back to the Atom editor, and we change the method GET by POST. We also change the URL. This time, we're going to use the POST resource, http:/bin.org/post. And we add the data dictionary. This is typically the form data you see in a web application. In this case, we add one parameter in a data dictionary, with a key called name and the value packed. We save it, and then we run the script in the console. Perfect. We can see in the results that we have the dictionary form, with the values we have submitted. Congratulations! You now know how to perform different HTTP requests using Python. In this video, we have seen how to use the request library to perform GET, HOST, and POST requests that will be the foundation of the following scripts. In the next video, we're going to analyze the HTTP responses and learn the different groups of return codes. Hi, and welcome to the final video of this section. In the previous video, we started coding our first script to interact with web applications. In this video, we will learn about the different HTTP response status codes. We are going to learn about the different classes of HTTP response codes, and then write examples to see successful responses, errors, and finally, we're going to see a redirection example. The HTTP protocol defines 5 classes of response codes to indicate the status of a request. The 100 range codes are used for informational purposes. It is only present in HTTP 1.1. The 200 range of codes are used to indicate that the action requested by the client was received, understood, accepted, and processed. The most common is the 200 OK. The 300 range indicates the client that must take additional action to complete the request. Most of these codes are used in URL redirection. The most common of this group is the 302 found code. The 400 range are used to indicate that the client has had an error. The most common is the 404 not found. Finally, the range 500 is used to indicate an error on the server side. The most common is the 500 internal error. We suggest you learning the different codes in each group here. developer.mozilla.org/en-us/docs/web/response_codes. Let's write some code. Let's open our editor in the virtual machine and create a new file. First, we import requests library by typing import request. And we create a variable for our target URL. We are going to use http://bin.com again. And then we print the response code with rec.status_code. Print response code the string of rec.status_code. That's it. We save the file. In example section 2 as video-4.py, and we switch to the terminal to run the script. We use Python video-4.py. And there, you should see a 200 status code in the response, meaning that our request was successful. Well done. Let's move on. Let's go back to the editor. Now, let's change the target URL by something that is not existent. In order to see an error code, we'll change the URL and write fail here. Let's save it and run this script in the terminal again. Now, running the server is returning a 404 status code, meaning that the resource was not found on the server. So now we know that we can ask the server for a list of directories and files, and find which ones exist or not. Interesting, right? Now, let's see how we deal with redirections. We are going to use an example page that will take a parameter URL and will redirect us to that defined URL. Let's go back to our script and modify it in order to get a new directory called payload, which will contain the URL where we want to be redirected. We'll use payload equals URL to be redirected to www.bing.com. Now we'll use this, the resource redirect to, and we'll add the params parameter and set it to the payload. Finally, we'll print the content with printrec.text. We'll save it and we'll run it again. What do we get now? A code 200, okay? And the content of www.bing.com. The code should be 302, right? We need to access the history of the request to see the redirects. Let's add print r.history. The history is a list of all the responses in the redirection chain. We will print the URL and the response code for each URL with this loop to our script. For x in rec.history, print this status code concatenated with the URL. We can remove the rest of the code below. We save it and run it. Now we see that before the 200 there was a 302 redirection code, sending our browser to the www.bing.com. Congratulations! You've finished section 2. In this section, you learn how to interact with a web application using Python and requests library. We also learnt about the HTTP request anatomy and the different HTTP methods and response codes. In the next section, we're going to learn how to write a web crawler, Spider, using Python and Scrapy library. Hi, and welcome to section 3. In the previous section, we learned how to interact with a web application programmatically using Python and requests library. In this section, we will learn about web application mapping. Then, we're going to build our first crawler with Scrapy. And finally, we're going to make it recursive and make it extract interesting information about the web application. Now, we move on to the first video of this section that covers what is web application mapping. In this video, we will learn about what application mapping is, why it is important, and finally, we'll see an example of how Burp Suite creates the map of an application. Remember in section 1, we learned about the penetration testing process. In that process, the second phase was mapping. In the mapping phase, we need to build a map or catalogue of the application resources and functionalities. As a security tester, we aim to identify all the components and entry points in the app. The main components that we are interested in are the resources that take parameters as input, the forms, and the directories. The mapping is mainly performed with a crawler. Crawlers are also known as spiders, and usually they perform scraping tasks, which means that they will also extract interesting data from the application, such as emails, forms, comments, hidden fields, and others. In order to do application mapping, we have the following options. The first technique is crawling. The idea is to request the first page, parse all the content, extract all the links in scope, repeat with the links discovered until the entire application is covered. Then we can use an HTTP proxy to identify all the resources and links that may be missed by a crawler. Basically, most of the URLs that are generated dynamically in the browser with JavaScript will be missed by the crawler, as the crawler does not interpret JS. Another technique is to discover resources that are not linked anywhere in the application by using dictionary attacks. We are going to build our own bruteforcer in the next section. Here, we have an example of how burp proxy creates the application mapping using the proxy and the spider functionalities. We can see the directories, the static pages, and the pages that accept parameters, with the different parameters and the different values. All the interesting parts will be used for handling vulnerabilities using different techniques like SQL injection, cross-site scripting, XML injection, LDAP injection, etc. Basically, the aim of mapping is to cover all the application in order to identify the interesting resources for the vulnerability identification phase. In this video, we learned what application mapping is and why it is important. In the next video, we'll start developing our own crawler. Let's get ready! In the previous video, we saw what web application mapping is. In this video, we're going to create our first Scrapy project. We are going to define our objective, create our spider, and finally, we are going to run it and see the results. First, we need to define what we want to accomplish. In this case, we want to create a crawler that will extract all the book titles from www.packedpub.com. In order to do so, we need to analyze our target. If we go to the www.packedpub.com website and we click Inspect on a book title, we see the source code of that element. We can see, in this case, that the book title has this format. Here, we can see div with a class of book, block, title, and then the title name. Keep this in mind, or in a notebook better. We need this to define what we want to extract in our crawl process. Now, let's get coding. Let's go back to our virtual machine and open a terminal. In order to create our crawler, we're going to change to the examples section 3 directory. Then, we need to create our project with the following Scrapy command. Scrapy start project, and then the name of the crawler, which in our case is basic crawler. When we create a project, Scrapy automatically generates a folder with the basic structure of the crawler. Inside the basic crawler directory, you will see another folder called basic crawler. We are interested in working with the items.py file and the content of the spiders folder. Those are the two files we are going to work with. So we open the Atom editor, add our project with add a project folder. Examples, Section 3, Basic Crawler. Now, we open items.py in the Atom editor. When working with Scrapy, we need to specify what are the things we are interested in getting while crawling a website. These things are called items in Scrapy, and think about them as our data model. So let's edit the items.py file and define our first item. We can see the class basic crawler item was created. And here we're going to create a variable called title, and that will be an object of the class field. Title equals scrapy.field. We can delete pass as it is not used. This is all for now with this file. Let's move on to our spider. For the spider, we're going to work on the file spiderman.py, which was created for this exercise in order to save time. We first need to copy it from examples/section3/spiders/spiderman-base.py to /examples/section3/basic crawler/spiders/spiderman.py. Then open the file in the editor, and we can see at the top of the file the imports needed for this to work. We have base spider, that is the basic crawling class. Then we have the selector, which will help us to extract data using crosspath. Basic crawler item is the model we created in the items.py file. And finally request that will perform the request to the website. Then we have the class mySpider, which has the following fields. The name of our spider, which is needed to invoke it later. In our case, it is basic_crawler. Then there is allowed domains, which is a list of domains which are allowed to be crawled. Basically, to keep the crawler in bounds of the project. In this case, we are using packedpub.com. Then we have the start URLs. This is a list that contains the starting URLs where the crawler will start with the process. In this case, it is www.packedpub.com. Then we have the function parse. As the name suggests, here is where the parsing of the results happens. We instantiate the selector, passing it the response of the request. And then we define the variable book_titles. That will contain the results of executing the following crosspath query. The crosspath query is based on the analysis we performed at the beginning of the video. This will result in an array containing all of the book titles extracted, with the defined crosspath from the response content. Now we need to loop that array and create books of the type basic crawler item and assign the extracted book title to the title of the book. That's all for our basic crawler. Let's go to the terminal and change the directory to basic crawler and then run the crawler with Scrapy crawl followed by basic crawler. All the results are printed in the console, and we can see the book titles being scraped correctly. Now, let's save the output of the folder in a file by adding -o books.json-t, followed by the type of the file, that is JSON. Now, run it. We open the file books.json. with vi books.json. And and we can see the book titles being extracted as expected. There are some extra tabs and spaces in the titles, but we got the name of the books. This will be the minimal structure needed to create a crawler, but you might be wondering that we are just scraping the index page, and how do we make it recursively crawl a whole website? That is a great question, and we're going to see it in the next video. In this video, you have created your first web application crawler based on Scrapy and Python. Well done! In the next video, we're going to improve it and make it recursive to improve the coverage of the crawler. In the previous video, we learned how to create a basic web application crawler. In this video, we will be adding recursion capabilities. In this video, we're going to start learning how to extract links, and then we're going to use them to make the crawler recursive. Now that we have created the basic structure of our crawler, let's add some functionality. First, let's copy the prepared spiderman.py file for this exercise. Copy from examples/spiders/spiderman-recursive.py to basic_crawler/spiders/spiderman.py. Then we go back to our editor. As we would like to make the crawler recursive, for this purpose, we will work again in the spiderman.py file, and we will start with adding another extractor, but this time for links instead of titles, like here. Also, we need to make sure that the links are valid and complete, so we're going to create a regular expression that will validate links seen here. This regular expression should validate all HTTP and HTTPS absolute links. Now that we have the code to extract the links, we need an array to control the visited links, as we don't want to repeat links and waste resources. Finally, we create a loop to iterate over the links found. And if the link is an absolute URL and has not been visited before, we yield a request with that URL to continue the process. If the link failed the validation, means it is a relative URL, so we will join that relative URL with the base URL, where this link was obtained from, creating a valid absolute URL, and we yield request. We save it, and then we go to the console. We change directory to basic crawler, and we run it. Scrapy, crawl, basic, crawler, -t, JSON, -o, test.json, and enter. We can see that it is working now, and we are recursively crawling and scraping all the pages in the website. This could take a long time, so we cancel with Ctrl+C, and we're going to get the file with the results up to this point. Let's open the file test.json. And we can see that we have a lot of book titles from multiple pages. Congratulations! We have built a web application crawler. Think about all the tasks you can automate now. In this video, you learned how to extend your crawler and make it recursive to cover the whole web application. In the next video, we're going to see how to extract other interesting information from the web application. In the previous video, we learned how to make our crawler recursive. In this video, we're going to take a look at how to extract other interesting information that will be useful for our security analysis, like emails, forms, and comments. We have added recursive capabilities to our crawler. Now, we're ready to add more features. In this case, we'll be going to add some extraction capabilities for emails, because it's always useful to have valid accounts, which could be handy during our tests. Forms, Will be useful to know where there is information being submitted from the browser to the application. Comments could provide interesting information, which developers may have left in production without realizing. There is more stuff that you can obtain from web applications, but these are usually the most useful. First, let's add these fields into our item. Open the file items.py in Atom and add email equals scrapy.field, form equals scrapy.field, comment equals scrapy.field, PDF equals scrapy.field. And finally, location_URL equals scrapy.field. This will be used to indicate where the information was found. So let's get back to the spiderman.py file. Let's copy a prepared spiderman.py file. We're going to copy examples spiders spiderman.py to basic crawler spiders spiderman.py. Let's go back to the editor. In order to extract emails, we need to add the following to our spiderman.py file. The email cross-path extractor. This selector could yield some false positives, as will extract any word that contains an @ symbol. And then the loop to store the results detected by the selector into our items. And that's it. With the code, we're now going to extract all the email addresses we find during crawling. Now we need to do the same to extract forms actions. The cross-path will get the action attribute for the forms, which points to the page that will process the data submitted by the user. Then we iterate over the findings and add it to the items. That's it for forms. Now let's do the same for code comments. We create the extractor. And again, we iterate over the results and add it to the items. Now we can run the crawler and see the results. Let's go back to the terminal, and in the basic crawler we'll type Scrapy crawl basic crawler -o results.json -t json and hit enter. It will take a long time to finish the crawling. We're going to stop it with Ctrl+C after a while. Once it's finished, we can open up the results.json with the Atom editor and inspect the results. Congratulations! You extended the crawler to extract interesting information about a website. You can see the results: form, comments, many comments, another form here is an email, and so on. The results for just a few seconds, we have around 1,300 items. I suggest you looking at other ways on how to deal with the results, like parsing them, storing them into SQLite or MongoDB. Congratulations! You have created your first web crawler using Python. In this section, we learnt how to develop a web application crawler using Python and Scrapy library. This will be useful for mapping the web application structure and to harvest interesting information like forms, emails, and comments from the source code of the pages. Now that we know how to map a web application using a crawler, but most of the applications have hidden resources. These resources are not accessible for all the users or are not linked by all. Luckily, we can use brute force technique to discover directories, files, or parameters in order to find vulnerabilities or interesting information to use further in our tests. In the next section, we're going to write a tool to perform brute force attacks in different parts of the web application. Hi, and welcome to Section 4, Resources Discovery. In the previous section, We saw how to write our own crawler using Python and the Scrapy library. In this section, we're going to learn what resource discovery is and why it is useful when testing a web application. We're going to start by creating our own bruteforcer with Python and requests library, and then we will improve our bruteforcer in order to get better results. Finally, we're going to take a screenshot of the resources detected. Let's get on with the first video. In this video, we're going to learn what is resource discovery and why it is important when testing web applications. Also, we're going to introduce fuzzDB, which is going to be used in the next videos as our dictionary database. Again, remember in section 1, where we learnt about penetration testing process? In the process, the second phase was mapping. In the mapping phase, we need to build a map or catalogue of the application pages and functionalities. In the previous sections, we learned how to perform application mapping using a crawler. We also learned that crawlers have some limitations. For example, links generated with JS are not identified by crawlers. This could be overcome by using HTTP proxies or using a headless browser like Phantom.js. Still, if we use all those, we're going to identify all the resources that are linked somewhere in the web application. But my personal experience has shown me that we can find many resources that are not linked. In order to discover these, we need to perform resource discovery via dictionaries of known words. These kind of tools are known as dictionary attacks. Basically, because we're going to use a list of known words in order to identify the resources. Brute forcing, because we are using brute force in order to identify resources when using a list of permutations or combinations of strings. Fuzzing, not really correct, but many times used to refer to resource discovery. What can we find using this technique? Files, such as backup files, test files, notes, scripts, documentation, and examples. Directories, such as admin interfaces, backups, internal areas, upload directories, actions. Whenever there are verb names in options or parameters, we can use dictionary of similar words to identify other functionalities. Servlets, which are similar to actions but with file. Parameters. We can enumerate ranges or combinations of potential valid strings used in parameters. In order to be successful when we are doing resource discovery, you need to have good quality lists. There are many dictionary databases where you can find many word lists appropriate for different environments or scenarios. fuzzDB is one of the most used and complete databases available on the internet. We are going to use it in our next video. For resource discovery, we're going to focus on the Predictable Resource Locations Dictionary. I recommend you take a look at it in our virtual machine, under the code samples for this section, and get familiar with the different dictionaries or string lists available. In this video, we learned what resource discovery is and why it is important when testing the security of a web application. In the next video, we'll start developing our own brute forcer. Let's get ready! In the previous video, we learned what is a brute forcer. In this video, we're going to build a script that will help us in discovering resources using a dictionary of words. We are going to create a basic brute forcer. We're going to start defining the objective of the tool, and then we're going to go over the code of the basic structure of the brute forcer. Finally, we're going to run it against our test web application. We are going to go back to our editor and open the project folder for section 4. Then we open the file forzabruta.py. In this script, we have the basic structure for our brute forcer. We have our typical imports, and then we have the banner function that will print the name of the script, the usage function that will print a help on how to use the script. Now, let's jump to the function start, which is invoked when we run our program. We print the banner and then check the parameters used to invoke our program. We will then parse the parameters and assign the URL, dictionary, and number of threads. We'll open the dictionary and read all the lines. And finally, we'll call the launcher_thread with the dictionary, threads, and URL. As we want our application to perform several tasks at once, you can use threads. Otherwise, our bruteforcer will be sequential, and for big dictionaries, it will be slow. By using threads, we can speed up this attack. You can reuse this script skeleton whenever you want to implement threading in other tools. As usually, threading is tricky to implement. The function launcher thread will basically manage the threads and will instantiate the class request performer for each thread, with one word from the dictionary and the target URL. Then it will start the thread. This will be done for each word that is loaded in the dictionary. The thread instantiates the class request performer. This class has the init method used to set up the object, after it is created, that is. Basically, the constructor. In this case, we basically create the attributes self-word and self-URL, which will replace the tag fuzz with the dictionary word. Then we have the method run, which will perform the request and will print the URL requested and status code. Finally, we'll update the thread counter. When the words from the dictionary are consumed, the program will be completed. This is the basic structure for a bruteforcer. Let's see an example with our vulnerable test application. Let's go to the terminal and type execute python forzabrute.py. Then we have the first option, that is the target URL, where the word fuzz is the token that will be replaced by every word in the dictionary. It is the position that we want to test. In this case, dictionaries and files in the root directory in the test application. Then we have the option -T5, that is the number of threads we want to use. And finally, option -T comment.txt, which is the dictionary file created for this exercise. It is pretty simple, but remember, in real test, you'll need to use FuzzDB dictionaries. Once we run this, you should see the results. We have one result per word in the dictionary. We have some valid 200 status code and 401, which means authentication needed, and many 404, not found codes. Let's see some examples in the browser. I'm particularly interested in the /admin directory. When I request /admin, we can see we get an authentication form pop up needing username and password. We'll come back to this later. Now, let's see if robots.txt has anything interesting. There are 3 entries in the robots.txt. One is /admin, and the other is the includes directory. We knew of admin already, but back office looks interesting as well. Many a times, robots.txt provides some interesting findings for our testing purposes. Wow, congratulations! You wrote a basic HTTP bruteforcer. The current script is pretty basic, and the results are not that great, but we're going to improve them in the upcoming videos. In this video, we learnt how to create a basic bruteforcer. In the next video, we're going to learn how to improve it and add more features. Hi, and welcome to the third video of section 4. In this video, we will improve the bruteforcer we created in the previous video, in order to facilitate the analysis of the results. In this video, we're going to see how we can improve the results. We are going to add those improvements to our code, and finally, we're going to test the code with our testing web app. In the previous video, we created a basic bruteforcer, but we saw that the results were a little basic. And when we have a lot of results, it won't be easy to identify the interesting findings. so we can add colors depending on the status code. A good start will be to print in green all the results which have a status code greater or equal to 200 and lower than 300. In red, the results with status codes greater or equal to 400 and lower than 500. And finally, in blue, the results with status code greater or equal than 300 and lower than 400. This will help us to quickly identify results. Our interest will be mainly in the green and the blue results. We can also enrich our results with more information about the responses, like the number of characters, the number of words, and the number of lines. This will help us to tell apart pages that are returning the same content from multiple resources. So we'll be able to identify when this is the case by looking at the characters, words, or lines. Finally, we'll add the option to filter or hide results based on the status code. This will be useful to remove the non-found responses. That usually should be 404, but many times developers customize their apps or servers to return 200, 301, or 302. Let's go back to our editor and open the file forza-bruta-2.py. We'll add some more imports like term color, which will allow us to print colors in the terminal, and re for regular expressions. In request performer, we obtain all that information from the response with lines, counting the number of new line characters in the response, chars, which calculates the number of characters, words, number of words in the response, and finally, the status code. Now we'll add them all to the result output. This chain of conditions will allow us to filter on non-interesting responses, with a code equal to a specific hide code, and to visualize other kinds of requests with 3 different colors. We are going to use green for status codes greater than or equal to 200 and less than 300. Red for codes greater than or equal to 400 and less than 500. And blue when the result is greater than or equal to 300 and less than 400. Now, we need to add a new parameter in our program. We add -c in the getOp parameters, and then we assign the value of -c to the variable hide code. We pass hide code to the launcher thread here, and then to request performer. In request performer, we add a condition before printing, in order to filter out the codes we are not interested in, usually 404. Let's go back to the terminal and run the program. We'll change to forza-bruta-2.py and run. You can see the results are much easier to read and identify quickly the different codes. Let's try it again, adding the parameter -c and hide response 404 to the command line. This is much better. This will help us to quickly identify where the interesting stuff is. But seems that test1.txt and test2.txt are the same files, right? They have the same number of lines, chars, and words. Let's open them in the browser. Text1.txt only has AAA. Now let's open test2.txt, and the content is BBB. They are not the same, but with our current tool, we won't be able to tell these files apart. Let's see on our next video how we can solve this. In this video, we added new features to our bruteforcer in order to improve the results and help us with the analysis of our target web application. In the next video, we're going to continue adding more features like content hashing, timing, and headers that will help us to be more granular when filtering. Hi, and welcome to video 4 of section 4. In this video, we'll continue adding features to our bruteforcer in order to improve the detection and facilitate filtering. First, we're going to add the code that will detect if there was a redirection. Then we're going to add the time it took for the request-response transaction and the MD5 hash of the response. Finally, we're going to test the improved script. Currently, the requests library returns a 200 status code for resources that followed a redirection, as it is returning the status code from the last resource in the redirection chain. If we want to know if there was a redirection, we need to check the history of requests. Let's go back to the Atom editor and open the file forza-3.py. We need to add this code in order to improve the redirection detection. After line 48, after we get the request response. This code will check if there was a redirection, and it will update the code with the first redirection code. For the request time, we can do the following. Take the time before the request, take the time after the request, and then subtract the start time from the elapsed time. In order to do so, we're going to use the time library. We'll add the import library at the beginning as seen here. Then, we add this line before the request in order to capture the time at that moment. And we do the same after the request is performed. Then, we subtract the start time from the elapsed time, and we get the time it's taken by the response to arrive. Let's move now to the last part of the video. Remember, in the previous example, when the files test1.txt and test2.txt, which had similar results? That was because the number of lines, chars, and words were the same. But there will be times that you will need to know when there is an exact difference in the content, and in order to solve the issue, we can calculate the MD5 hash of the content to get unique fingerprints of the resources. We need to import MD5 and add this code. That hash will be unique and will be useful for filtering resources with similar chars, words, lines, and code. Let's try it. Now, let's try it again. Let's go back to the terminal and run forza bruta 3 with the same parameters as before. Now this is looking way better. The results are very rich now. Check out the difference in the MD5 hash for test1.txt and test2.txt. Cool, right? We have a value to tell them apart now. And also, we can see the redirection in blue instead of a 200 result. What if we want to look just for .php files? We just need to add .php after the fuzz string. Also, we'll change to commons as it is a bigger dictionary for this scenario. Let's run it. You can see that we have many new results to investigate. Great stuff! Well done. You now have a functional web application bruteforcer. What if we want to make the bruteforcer to take a screenshot of the resource that returns a 200 status code? Let's see that in the next video. Hi, and welcome to the last video of this section. In this short video, we're going to learn how we can take a screenshot automatically from our bruteforcer. In this video, we're going to see why taking pictures could be useful and which libraries we need to add to be able to add this capability to our script. Finally, we're going to run the new bruteforcer and take some pictures. What do we want to achieve in this video? Basically, we want to take a screenshot of every resource that returns a 200 code. This will help us to speed up the analysis of our big apps, or when testing multiple apps in a short period of time. For this, I choose Selenium WebDriver for Python and Phantom.js. Selenium WebDriver is a tool used to automate web browsers programmatically, mainly for software testing purposes. Selenium WebDriver will drive Phantom.js, which is a headless browser, and will have access to Phantom.js capabilities in Python. In this case, the screenshot function. But we can also access the DOM, which would be very useful for testing DOM injections. I installed Selenium and Phantom.js in the virtual machine to facilitate the training. Let's see how to add this to our bruteforcer. Let's go back to our editor and open forza-bruta4.py. We're going to add in the import area the following Selenium libraries: the WebDriver, keys, and capabilities. We define the capabilities where we specify we want to use Phantom.js. Then we instantiate the WebDriver with the capabilities. Then we wait 2 seconds just to make sure the page is loaded. We define the size of the screenshot. Then we load the page, and finally we save the screenshot with the name of the resource found into word.png. Short and easy, right? Let's run it now. Let's go back to the terminal and run forza-bruta-4.py with the same parameters as before. We see there are some delays, but they are caused as we waited a couple of seconds just to make sure the page is loaded. Now, if we look into the directory we just run the script, we should see a few .png images. Let's open index.php.png. This is the screenshot of the content of index.php. Then we can open the robots.text.png, and finally the test1.txt.png. We can see the content of the files. Very interesting, considering we are using two tools in order to automate the screenshots: Selenium, that will let us drive Phantom.js, which in turn lets us take a screenshot. Congrats! Now you have the knowledge to expand the bruteforcer and add anything that you could need in the future. Some recommendations for further development is filtering by lines, words, chars, and MD5, adding recursion when detecting a directory, and generating an HTML report of the results. And with this video, we finish section 4. In this section, we have learnt how to write a bruteforcer tool that will help us to discover and enumerate resources like files, directories, and parameters. We saw how to add filtering capabilities, and we saw how it can be extended in order to add more information and capabilities that will help us to filter responses and identify the interesting ones. Finally, we saw how we can take screenshots automatically using Selenium and Phantom.js. In the next section, we're going to learn about password quality testing, or also known as password cracking. Hi, and welcome to section 5, password testing. In the previous section, we have learned how to write a basic web application bruteforcer to help us with the resources discovery. In this section, we're going to learn different types of authentication methods that a web application can use, and we're going to develop our own web application password cracking tool with Python. In this section, we're going to learn how password attacks work, the different methods of authentication, and then we're going to start creating our password cracker with Python. The different methods we're going to cover are basic authentication, digest authentication, and finally, form-based authentication. Let's move on to the first video in this section, how password attacks work. In this video, we're going to take a look at what is password cracking, which is also known as password testing. We will cover the different approaches we can take when doing password cracking, and finally, we're going to learn about password policies and account locking, which is important when planning a password attack. Password cracking is the most common type of brute force attack against web application. It is an attack against the login credentials, and it exploits the fact that passwords are usually weak, due to the fact that users need to remember them, and they need an easy-to-remember word. Password cracking is usually done with a dictionary of known words, or more exactly, with the list of well-known and widely used passwords. These lists were created by taking the most used passwords from the list of passwords leaked from different online services. Password lists may also include variations of words, as those generated by replacing letters by numbers, like O with 0 and I with 1. When we plan a password attack, we have different options on how to do it. The most common and most used is the vertical scanning, which takes one username and tries all passwords in the dictionary. The second option is called horizontal scanning, which is basically the opposite of vertical. It takes a password and tests it against all usernames. This is usually done in order to prevent account locking after many invalid login attempts. The next approach is called diagonal scanning, and basically it mixes a different username and password each time, reducing the possibility of being detected or blocked. But sometimes that is not enough, and we need to go further in order to prevent detection. This is when three-dimensional scanning comes into play. This is a combination of horizontal, vertical, or diagonal, but in this case, we have multiple machines that we can launch our request on, or HTTP proxies that will allow us to use different source IPs for each request. And finally, four-dimensional scanning is adding a time delay per request on top of source IP rotation or distribution. A password policy is a set of rules designed to enhance computer security by encouraging users to employ strong passwords and use them properly. The password policy may either be advisory or mandated by technical means, like forcing it at the time of account creation or when the password needs to be changed. The password policy could dictate length of passwords, case sensitivity, mix of lower and upper case, characters allowed, characters, numbers and symbols, reuse of past passwords, how many previous passwords you can't use, blacklisted passwords, very easy to crack like password and 123456. And also, it can define things like how frequently you need to change your password and to lock the account after X number of wrong attempts. So, now that we understand how password policy works, we have to be careful when we launch a password cracking test, because we can end up blocking thousands of accounts, and that could mean the end of the penetration test, and some problems for us. Again, this is illegal to perform without authorization. In this video, we have learned about password testing, the different approaches that we can take when planning a password brute force attack, and how developers and administrators can define password policies to enforce security. In the next video, we're going to learn how to brute force basic authentication. Hi, and welcome to the second video of Section 5, creating our first password brute forcer. In the previous video, we talked about password cracking along with its different approaches, and we learnt about password policies. In this video, we're going to create our first password brute forcer, targeting the basic authentication method. In this video, we're going to look at what basic authentication is, how it works, and then we're going to create our first password brute forcer for this method. Finally, we're going to test the script against our victim web application. Basic authentication is one of the simplest techniques for enforcing access control to web application resources. It is implemented by adding a special HTTP headers, and it's insecure by design as the credentials are being sent encoded with base64 method. Encoded means that it can be reversed easily. For example, we can see how basic authentication header looks like. The encoded string can be decoded, and we found that the password being sent is equal to admin123. Usually, when you see a string that ends in equals, it could be a base64 encoding string. Let's create our password cracker. Let's go back to the Atom editor and open the file back to basics.py in section 5. We can see that in the important area we don't have anything new, and the structure of the script is pretty similar to the previous one. We have the start function that will show the banner, and it will pass the command line and read the parameters. Same parameters except we have the user parameter now. Then it will invoke the function launcher thread with the variables password, threads, user, and URL, which corresponds to the dictionary of passwords, the number of threads, the username to be used, and the target URL. Then, in launcher thread, we have a while loop that will continue until we don't have any words left in the array passwords. So, for every word in the array, we do a pop. Then we instantiate the request performer class with the password, the username, and the URL. In request performer, we define some attributes to the object, and then we execute the get request. The important bit here is the auth parameter, which tells requests to use basic authentication with the provided username and password. Then, if the status is 200, we print that the password was found and the password used. We use the variable hit in order to control if we found a valid password and stop sending requests. That's it. Now we have our first basic authentication bruteforcer. Let's try it. Before running it, remember in the previous section that we discovered different directories, and there was one that returned the status code of 401. That means that it is requesting authentication. Let's try it on that one. The directory was admin, and when we try to access it, we can see the authentication pop up. Let's go to the terminal. We are going to run it with the following command line: Python back to basics.py, then the URL we want to access, followed by the username, which in this case is admin, then the number of threads, and finally, we are using the common-pass.txt file that I created for this exercise. It is very simple, but it is for demonstration purposes. We can see that the password for the user admin is administrator in this case. Let's try it on the website. Perfect. Now you know how to perform a basic authentication password test in web applications. In this video, we learned about basic authentication, and we created our first password bruteforcer that can deal with basic authentication. In the next video, we're going to see another authentication method, and we're going to modify our script to include this option. Hi, and welcome to video 3 of section 5, where we are going to add support for digest authentication to the password bruteforcer that we created in the previous video. In this video, we're going to start learning what digest authentication is. Then, we're going to modify our password bruteforcer to support this method. And finally, we're going to test the new script against our test web application. Digest authentication is a more secure option to basic authentication. It uses MD5 to do the hashing of the username and password, plus a nonce. The nonce is used to prevent replay attacks, and it is sent by the server after the user requests a protected resource. So when the browser will create the response with this code, #1 is equal to MD5 hash of username realm password. #2 is equal to MD5 method digest URI. Finally, the response is MD5 hash of HA1 nonce HA2. Realm value defines a protection space. If the credentials work for a page in one realm, it will also work for other pages in that same realm. Now, let's add the support for digest on our script. Let's go back to our editor and open the file back to digest.py. We added a few lines to add the support for digest authentication. First, we added this import. That allows us to select the authentication. In a request performer, we need to add a condition to check if the user chooses to run a digest authentication attack or basic. We specify the different methods in the request instantiation. In the case of digest, it is slightly different, as we need to specify HTTP digest auth in the auth parameter. Also, we need to add in the start the handler of the new parameter. We add the M in the getOpt function, the new parameter that will manage the type of authentication method, and we'll add it to every function as a variable. That's it. We should be ready to test against the digest protected resource. Let's do it. Let's go back to the terminal, but first, let's check the resource backoffice that we found in the robots.txt. We can see that it needs authentication, and to the user, it is exactly the same as basic authentication. But if we look at the headers of the response that the server sent us, we can see that there is a www authenticate header with the digest realm parameter, the nonce, and the algorithm MD5. So let's go to the console to run our script. Let's run it against directory backoffice. We run the back2digest.py with the same parameters as before, but we change the resource to /backoffice instead of /admin. We change the user to administrator. We keep 5 threads, the same dictionary pass.text, and finally, the new parameter method indicating digest, and we run it. No luck this time. None of the combinations were valid. Maybe the user doesn't exist. Let's try another user. Admin, for example. Let's run it. Great, we found the password for the user admin. Let's try in the browser now. Username admin and password admin123. Perfect, we're in. Not much to see in here. Now you have your password bruteforcer that could do basic authentication and digest. Congratulations! Let's continue adding more functionalities. In this video, we learned how to extend our password bruteforcer to support digest authentication. In the next video, we're going to learn how to test the most common authentication method, which is the login form. Hi, and welcome to the final video of this section, where we're going to learn how to brute force form-based authentication in web applications. We're going to start learning what form-based authentication is, and then we're going to modify one of our previous tools to enable this attack. Finally, we're going to test the script against our victim web application and fine-tune it to improve the result analysis. Let's start with a quick overview of form-based authentication. Form-based authentication is the most common and widely used method of authentication in web applications. This method is not as standardized as the previous 2 methods we learned, which means that the implementation of this method will vary. Basically, the web application will present a form that will prompt the user for the username and password. Then, that data will go to the server, where it is going to be evaluated, and if the credentials are valid, it will provide a valid session cookie to the user, and it will let the user access the protected resource. Let's add this to our previous script. So, you're probably waiting for me to say, let's go back to the editor and open the previous scripts. But no. Let's just stop for a minute and evaluate what is our best option here. We're going to deal with forms, and there is no standard on how to handle authentication on forms. So we'll need to have good filtering in order to weed out the wrong attempts and be able to identify the good ones. For this reason, instead of adding all the filtering code to the previous script, we add the post handling and payload handling to the forza-bruter-forms.py script from section 4. So now, go back to the editor and open the file. And let's start adding the code to enable it to brute force login forms. We don't add any new import. We can go to the start function and add the getOpt function for handling the post payload. In this case, it will be the letter P. Then, if P is present, we assign its value to the payload variable. We pass payload to launcher thread. Then, inside the launcher thread, we pass it again to request performer. We add the payload to the init function of request performer, and then we check if payload is empty or not. If not empty, we replace the keyword fuzz by the dictionary word. Otherwise, we don't touch it and leave it as it is. Then we go to the run method, and we need a conditional to tell when to use post and when to use get. We can do this by checking if self.payload is empty, in which case we use get. If it is not empty, we will be using the post request. For the post request, we need the payload in the form of a dictionary. Now, we have it as a string with ampersand and equals signs. So we're going to replace the symbols by one space. Then we're going to split the string by spaces, creating a list of elements. Then we create a post request using that payload. And those are all the changes necessary to be able to perform password brute forcing on login forms. Now it will be good to test it against our victim web application. Let's do it. Okay, how do we set up a brute force attack against forms? Let's open the page that has the login form. In our case, www.scrapybank.com/login.php. We right-click on the page and we select View Source Code. Now, we need to find the form action, that is, where the credentials are going to be sent to be verified. In this case, it is check_login.php, and also we need the name of the variables. In this case, username and password. That's the data we need to set up our attack. Okay, let's go back to the terminal and run the script with this command line, forzabruta-forms.py, followed by the same URL. This time, we change the login to check_login.php. We keep the threads to 5. In this case, we add the username and password parameters in the payload of the post. We need to concatenate the parameters with an ampersand. Weaksource.txt is a list of the weakest passwords used by people in different services. Now, let's fire this up. We see that all the results are 302. So filtering by code won't help us. We can filter out the chars equal to 2373 that we know that are failed attempts. Let's modify the code to filter the chars instead of the code with the command line parameter -c. We change the code to filter by chars. Doing so, we can filter by chars without modifying much of the code. We go back to the editor and we modify the line self.hidecode not equal to code to self.hidecode not equals chars. Let's save this. Now we change the command line to add -c 2373 to filter all results out. And we run it again. Sweet! We have our username and password. Congratulations! You now know how to test for password security against the 3 most common web application authentication methods. And in this section, we also leveraged from the previous work. In this section, we learned what are the different authentication methods commonly used in web applications, and we created one tool to test basic and digest authentication. And finally, we created a login form authentication brute forcer. In the next section, we're going to learn about detecting and exploiting SQL injection vulnerabilities. Hi, and welcome to section 6. In this section, we're going to learn about one of the most dangerous vulnerabilities that can affect web applications, SQL injection. In the previous section, we learned about the different authentication methods, and we created a password brute forcing tool. In this section, we're going to start by learning what is SQL injection and how it works. Then, we are going to learn how to detect a SQL injection and automate it with Python. Then, we're going to see how we can exploit the detected vulnerability and automate the actions we want to perform. Finally, we're going to learn how to detect blind SQL injection. Now we move on to the first video of this section that introduces what is SQL injection vulnerability. We're going to start explaining what is SQL injection vulnerability, explain how it works, and then we're going to learn about the differences between SQL injection and blind SQL injection. What is SQL injection? It is a type of input manipulation vulnerability. As the name suggests, it is vulnerability where the attacker manipulates the web application in order to inject arbitrary SQL code into the application database. This vulnerability affects mainly web applications that use DBs to store and retrieve data. Nowadays, most of the web applications use a DB, thus, the amount of web apps affected by this vulnerability is huge. The main cause for this problem is that the web application uses data that is coming from an untrusted source to dynamically construct a SQL query. If the injection is successful, attackers can extract arbitrary data, insert tampered data into the database, bypass authentication authorizations and access controls, take control of the server by executing OS commands. As you can see, it allows you to do a lot of things in the web application, which for an attacker is pretty good. Imagine we have a login form on our web application. This login form will be handled by our server-side code that will obtain the username and password from the post content. It will be assigned to the variables the name and pass. Then these two variables will be used to dynamically construct the SQL statement. When our users provide valid usernames and passwords, like admin and superroot, the login will be successful. But what will happen if a user provides special characters and structure to his input? Let's imagine the same example, but this time the attacker will insert a single quote or 1=1 as the name and password. What will happen here? The resulting SQL query is valid. It will return all rows from the table users, since where 1=1 is always true. This means that it will return all the results in the user's table. In the case of this login screen, it will log the attacker in with the first users of the table. Many times, the first user is admin, except if there are some users called Aaron, Anshal, etc. When a web application is vulnerable to an SQL injection, but the results of the injection are not visible to the attacker, it's called blind SQL injection. Admins, developers and frameworks are handling errors in order to avoid leaking information. When no results or errors are visible to the attacker, we still have some methods that could help to exploit the SQL injection in a blind way. The first method is called Boolean. This method is based on injecting payloads that alter the outcome of the original query, which results in different returned page content. The other method is time-based. This method is based on injecting payloads that trigger a delay time for the SQL server while processing our query, which in turn slows down the response time of our request. We're going to learn more about these techniques in more detail later. In this video, we have learned what is a SQL injection vulnerability, how it works, what is a blind SQL injection, and what methods we have to deal with blind SQL injection. In the next video, we're going to learn how to detect SQL injections and automate the task with Python. Hi, and welcome to the second video of Section 6. In this video, we're going to learn how to detect SQL injections and how to automate this in Python. In the previous video, we learnt how an SQL injection vulnerability works. In this video, we're going to look at what are the different methods to detect an SQL injection in a web application. Then we'll proceed to automate the detection of these issues based on one of the methods. And finally, we'll enumerate the columns used in the query and also identify valid column names in the table. In order to detect SQL injection, we have three methods available. Error-based. This method injects payloads that break out of the original query and generates an SQL error on the server, which can be detected in the content of the returned pages. Boolean. This method injects payloads that alter the outcome of the original query, which makes the application return a different page content. Basically, we identify the size of a valid page versus the size of an invalid page, and then we perform Boolean queries like the one we can see here. If the first number of the version of the database is 5, we're going to get the page of the ID 1008. If not, we're going to get the error page. If we want the exact database version, we need to automate this query and guess the value for each position. Time-based. This method injects a payload that triggers a delay in the SQL server while processing the query. If this delay is big enough and there is no considerable lag in the network, we can tell whether the query was executed correctly. Let's go back to the editor and open the file SQL Injector 0. In section 6, SQL Injector 0. It's important to highlight that all the content and scripts are based on MySQL database and will only work with this database. In the import section, we have the same content we were using in the previous video. Then we have the typical banner and usage functions. Then we have the start function, nothing new. Then the common options. We have two parameters, the URL to test and the dictionary of injections. Then we move to the function launcher. It is one that will replace the fuzz token by all the injection strings provided in the input file. It will then call the injector and print the results. The function injector is the next SQL injections based on errors. For this purpose, we have the array errors that has a limited number of strings we found in MySQL errors. Then we perform the request, and if we find an error, we add the URL to the results array, which finally will be printed in the launcher function. So let's try this script. Remember, there are some interesting files we identified with our brute force script in section 4. Particularly, there was one file that we needed to focus on. It's /users.php. This file seems to take an input and return the user and role for that user ID. Let's see what happens if we put 1. You can see we get a response with the ID 1, name, Johnny, and role, users, role test in this case. Excellent. Let's copy the URL to use as the input for our script. Let's go to the console and run the SQL injector with the following parameters. The URL that we copy from the browser and the injections file that we created for this exercise. And we press enter. Great! We can see the script detected the SQL error, generated by the following characters: single quote and parentheses. We can check the browser to see the error that these characters generate. Now here, replace this 1 by a single quote and enter. Cool! We can see that we're generating an SQL error, and we can manipulate that query. Let's move on to improving the SQL injector script. Now open the script SQL Injector 1. And you can see that we have two new functions, detect columns and detect columns names. Detect columns tries to identify how many columns are being used in the select we are trying to manipulate. This information is important in order to craft our SQL query. In order to do so, we use the order by technique. We can add order by x, where x is a number. If the number is less or equal to the number of columns, it will return results. If not, it will return an error. So if we try this until we get an error, meaning that the number of columns is less than x. Let's see in the browser. Now we try with a single quote space order by 1. We need to finish the query with minus minus. There should be minus minus to avoid errors. With 1 we get results, so they use at least one column. Let's try with 3. Unknown column 3 in order clause. This means that there are less than 3 columns. In this case, it will be 2. Yeah. Also, we have a new function called detect columns names. This function tries to identify valid column names in the table being used by the SQL query. This is useful because it will help us to tailor our query to extract data. We're going to use the group by technique. We add group by and a name of a column. If it exists, it will return valid results. If not, we get an error. The array column names has a list of interesting names of columns, but in reality, you need an extensive dictionary of words to identify as many columns as possible. Let's see the example in the browser. This time, we're going to use group, and we're going to use password as a column name. And then we hit enter. We can see that it is valid, and we are getting the admin results. But what if we use the username for the column name? We can add username in the group statement. We can see that the column username is not valid. Hence, we know the error message to identify invalid column names. Now, let's run the script in the command line. We change to SQL injection 1 and run it. We can see that we get the same results as before, plus the number of columns. In this case, the number of columns are 2, and some column names found are name, password, role, ID. Congratulations! You created an SQL injector detector. In this video, we have learnt about the different methods to detect an SQL injection, and then we created a script that will help to detect SQL injection based on database errors. In the next video, we're going to see what can be done once we identify an SQL injection, and then we're going to see how we can extract data from the database. Hi, and welcome to video 6.3. In this video, we're going to learn how to exploit SQL injections and how to automate this in Python. In the previous video, we have learned to create a script that will help us to detect SQL injections in web applications. In this video, we're going to learn what kind of data we can extract with an SQL injection. And then we're going to automate some of these techniques, like automating basic data extractions in our SQL injector script from the previous video. Once we identify a valid SQL injection, it's time to decide what we are going to look for. Here we have a list of the most typical things. Basic data. For example, database version, user running the database, current database, database directory, etc. Advanced data. MySQL username and password. Databases. Table names. Column names. Content from tables. OS files. We can read any file in the file system as long as the user running the database has privileges. These are some of the most useful and typically extracted data. I encourage you to continue learning what other things you can do once you have a working SQL injection. A good starting point is Pentest Monkey Cheat Sheet. The first thing we want to obtain after we get a working SQL injection is information about the database we are working with, like the database version, the current user, current database, etc. In order to do so, we need to use select @version. We'll obtain the database version. Select user. We'll get you the user that is running the database. For our example, we must use the following injection to get the version. Single quote, union, select 1, comma, @version, semicolon, dash, dash, space, dash. We need 1 before the @version to match the number of columns we have in the query. That has been affected by the SQL injection. In our case, there were 2 columns. That's why we add 1. Let's go to our editor and continue with the file SQL injector 2. We have added two new functions in order to obtain the version and current user from the database. You will notice that we have the following injection. The %20 is the URL encoded version of the space character. We are using concat command to concatenate the string toc at the beginning of the result and at the end. These strings will serve as tokens to identify the output of the query in the HTML result. Now we'll see the code we need to extract the version. We do this by processing the results using a regular expression to identify the tokens toc and extract the string found between them. We define the regular expression, then we use the findAll function from the re library on with the content of the request response, then iterate over the results. In this case, there should be only one. We will do the same process to get the database version, but using @version instead of user. Now, we want to obtain the MySQL usernames and password hashes. The query we need for this is select user, password from mysql.user, semicolon. Remember that this will only work if the user that is making the connection to the database has the privileges to access the table. Best practices recommend against this, but still, many people do it. We added the function steal_users to extract this data. We'll use the same techniques as before with the tokens to identify the output in the HTML results. Let's run it in the command line and see the output. We'll use the same command line as before. Now we can see the new data extracted. The database version is printed, in this case 5.6.28. It also gives us a hint on the OS, Ubuntu 15.10.1. And the user running the database is root, which means that we have high privileges, which will allow us to do more interesting things. Like, for example, accessing the table mysql.user, where the usernames and password hashes are stored. We can see the hashes for the user root and Debian, sys, maint, and phpMyAdmin. The repetitions are happening because the different host entries that are associated with each user. These password hashes can be cracked with a tool like John the Ripper if you need to do so. Great, we have a pretty good idea of the target. Let's continue extracting data. In this video, we learned about how to extract data from the database using SQL injection. We went from a simple error in the browser to extracting username and hashes from MySQL database. In the next video, we're going to expand on this and see how we can obtain all the table names from the database. And finally, we're going to read files from the OS through the SQL injection. Hi, and welcome back. In this video, we're going to continue adding features to our SQLi script. In the previous video, we saw how to extract data from the DB through an SQL injection vulnerability. In this video, we're going to add a function to read all the table names from the database, and we're going to add a function to read the files from the database server OS. First, we're going to see how we can obtain all the table names that are in the database in order to see if we see something of interest. And then we're going to add the capability to read files from the OS file system. Now, let's open the file sqlinjector-3.py. We have a new function in here that will help us to obtain the table names in the different schemas, except the ones we are filtering out to reduce the noise in the output. The structure is the same as before. We add the query we need, with the tokens to help parsing the results, and the regular expression for parsing it, and then we print the results. Finally, we add the function call in the launcher. Let's run it again in the command line. From the command line, let's run it with the same parameters as before. sqlinjector-3.py and the same parameters. Great! You can now see in the output we get the schema name and the table name. In this case, pyweb and phpMyAdmin are the schema, and the others are tables. User, users, etc. Let's move on to the last example. Let's go to the editor and open the file sqlinjection-4.py. This is pretty cool, and it opens a new world of opportunities for the attacker. And let's see the new function, read file. The query we're going to use to read files is this one. Basically, the new thing here is that the use of the function load file. We can use this function, which, as the name suggests, will load a file. And we'll put the content in the column we choose in the query. We're going to use it with a union. And then in the launcher, we need to call this function with the file we want to read. In this example, we are using file etc.passwd, the file that contains the users for the Linux OS. Let's run it in the command line. Use the same command line as before. And boom, we have the content of the exec password file. Now we can learn a little bit more about the system. Let's take a moment to think on all that we have achieved. By abusing a simple programming mistake, we are obtaining a vast amount of information from the database and the OS. And still, this is the beginning. I recommend playing with this until you are comfortable with the techniques. If something doesn't work, review your SQL syntax. It is very common to make mistakes at the beginning. In this video, we learned about how to enumerate the table names from the database using SQL injection. And we also learned how to read files from the OS file system via SQL injection. Remember to review the tools like SQL Map or SQL Brute to learn more about how these tools work. In the next section, we're going to learn about HTTP proxies, and we're going to create our own based on MITM proxy tool. Hi, and welcome to section 7. In this section, we're going to learn about HTTP proxies and how we can intercept and manipulate HTTP requests. In this section, we're going to start by learning what an HTTP proxy is and how it works. Then, we're going to explore MITM proxy, which is an HTTP proxy developed in Python. Then we're going to write scripts for MITM proxy that will allow us to manipulate the requests. And finally, we're going to see how to analyze and manipulate their responses. Let's move on to the first video of section 7, where we're going to learn about HTTP proxies. In this video, we're going to learn what is an HTTP proxy, why are proxies needed or used, and what types of HTTP proxies exist. Let's move on. First, let's see what is an HTTP proxy. An HTTP proxy is a server that acts as an intermediary between two communication parties. There is no direct communication between the client and the server. Instead, the client connects to the proxy and sends the request to it. Then the proxy will fetch the resources from the remote server and finally return the response back to the client. Why do we want a proxy? Because of privacy reasons, when we don't want the servers to know where we're coming from or who we are. For bypassing filters and censorship. In countries where internet censorship is common and services are blocked, proxies can help us to get around these blocks. Logging and eavesdropping. Many companies implement proxies in order to log what employees are browsing and to eavesdrop on their communications. Caching. Other companies use proxies in order to cache content and speed up communications. Filtering and blocking. Also, companies directly want to block and limit what services an employee could visit. Finally, to manipulate and modify traffic. As security testers, we are interested in intercepting the communications between our browser and the web applications in order to analyze and manipulate the requests and responses in order to identify vulnerabilities and also debug problems. When it comes to HTTP proxies, there are a few different distinctions that we should make. forward proxies. This is the most common example of proxies. It is the example we used in the explanation of what a proxy is. Forward proxies are the ones where the client sends the request to the proxy and the proxy fetches the resource on his behalf. In this case, the user chooses to or is forced to use a proxy in a company. The user knows that a proxy is being used, but the server doesn't. Reverse proxies. These are proxies used by companies in order to hide behind network architecture and mainly to distribute load between real servers. The user think they are connecting to a real server, but they are connecting to a proxy that will handle the request. Transparent proxies intercepts normal communications at the network layer without requiring any configuration on the client side. Usually, clients do not know they are using a transparent proxy. Transparent proxies usually do not modify requests and responses. They are commonly used by ISPs in order to provide faster responses to their customers. The proxy acts as a router or gateway. In this video, we learned what is an HTTP proxy, why proxies are needed, and the different types of proxy that exist. In the next video, we're going to learn how to use MIT-M proxy. Hi, and welcome to Section 7, Video 2. In the previous video, we learned about what is an HTTP proxy and what the different types of proxies we can find are. In this video, we're going to take a look at why we choose MIT-M proxy to work with, how to use the basic HTTP proxy feature in MIT-M proxy, and a brief introduction to MIT-M proxy inline scripts. MIT-M proxy is an interactive console program that allows traffic flows to be intercepted, inspected, modified, and replayed. After researching for this section, I decided that the easiest and most complete way to learn about HTTP proxies in Python is using MIT-M proxy. Any other attempt will be more complex and limited in the future than MIT-M proxy. MIT-M proxy is developed in Python and allows the users to extend it via their inline scripts. It supports SSL out of the box, unlike other alternatives out there that support only HTTP. Let's see how MIT-M proxy works in a simple example. If we go to the terminal and type MIT-M proxy, we get an MIT-M proxy console, listening at port 8080. If we change our browser settings to use proxy for HTTP connections, and we fire up a request like www.edge-security.com, we will see in the console all the requests. Let's go to Preferences, Advanced, Network, Connection Settings, Manual Settings, 127.0.0.1 8080 and hit Enter. Let's load www.edge-security.com in the browser now, and you can see the request history in the console. Now if you select Request and press Enter, you will see the details for that request, the response, the headers, and the connection details. If you want to edit the request, press E. When done, you can send it by pressing R. This is the basic usage of MIT-M proxy. I encourage you to learn about all you can do with MIT-M proxy at mitmproxy.org. It is really well documented. There are multiple examples, and you will find all the necessary information about it. Just to remind how proxies work, in this particular case, I have set up my browser to connect to MIT-M proxy on localhost in port 8080. The browser and the proxy are in the same machine. MIT-M proxy has a powerful scripting API that will let us access the requests on the fly to manipulate them. The MIT-M scripting API is event-driven, and a script is simply a Python module that exposes a set of event methods. We can see in the screenshot the example of a simple inline script that will add a new header to every HTTP response before it is returned to the client. That is all the code needed for the script. In the next video, we're going to learn how to write a script to manipulate requests in MITM proxy. In this video, we have learnt about MITM proxy, how to use it in a simple scenario, and we introduced inline scripts, which we are going to use in the next videos to manipulate the requests and responses. Hi, and welcome to the third video of section 7. In the previous video, we introduced MITM proxy, a Python HTTP proxy implementation that we will use to build our own HTTP proxy. In this video, we're going to learn more about inline scripts, and we're going to see an example on how to intercept the requests and access the different parts of it. In this video, we're going to start reviewing the inline script handler and learn what parts of the communications we can access. Then, we're going to write a simple script that will let us access the URLs requested and log them in a file. Finally, we're going to modify the requests by adding an arbitrary parameter to the query string. In the previous video, we saw a simple inline script was defined in order to access the response of a request. Here, there are other parts of the communication that MITM proxy lets us access via its handlers. Start, which is called once a script starts up, before any other events. Client connect is called when a client initiates a connection to the proxy. Note that a connection can correspond to multiple HTTP requests. Request, which is called when a client request has been received. Server connect is called when the proxy initiates a connection to the target server. Response headers is called when the response headers for a server response have been received, but the response body has not been processed. Response, which is called when a server response has been received. Error, called when a flow error has occurred. Client disconnect, when a client disconnects from the proxy. Done, called once the script shuts down after all other events. So now that we know what handlers are available to us, let's do an example where we access the requests. Let's open in the editor the script mitm-0.py, located in the source code for section 7. This script will basically log every request that the proxy receives from the client. We can see that this script is very simple. We have the handler for the requests, with the mandatory first parameter called context, and the second being flow. Flow, as the name suggests, holds all the information about the communication. In the function, we open the file http logs.txt, and then we write flow.request.url, which is the requested URL by the client, and we finally close the file f. Let's go back to the terminal in the same directory. MITM proxy console will come up. And then we will open our browser, and we change the proxy configuration for it to point to localhost 8080. Go to Preferences, Advanced, Network, Settings, Manual Proxy Configuration, localhost 8080, and we remove localhost and 127.0.0.1 from no proxy 4. Let's load www.scrapybank.com in the browser. You can see all the requests in the console. That is fine. Let's close the console and see the file http logs.txt. We can open it with the editor. And here we have all the URLs requested in the session. Excellent work! Now let's add a filter to log unique URLs to avoid storing duplicate URLs. Open the file mitm-1.py in the editor. In order to prevent duplicates, let's create a global variable in the script called history, and then in the function we just check that the URL is not in the history. If not present, we log it, and then we add it to the history. Let's try it again and see if it works. First, we can remove the http logs.txt file. Run mitm proxy-s mitm-1.py. Let's go back to the browser and open login.php and refresh it several times. Close the proxy console and open the results again. Great, no duplicates. Now that we know how to access the requests, let's see how we can add a query string parameter to every request. You may ask, why? Well, we need to add certain parameters in a request in order to access certain information. Let's open mitm-2.py. Now, what we are doing is we get the query string with flow.request.getQuery, and then we check if the query string has some content. If there is content, we add a new parameter called isAdmin, with the value true. And finally, we update the request query string with flow.request.setQueryQ. Let's try it in the command line. Let's launch mitm-2.py. And in the browser, click on the Learn More link that has parameters. In the MITM proxy console, you can see that MITM proxy is adding the query string parameter isAdmin with the value true. In this case, it won't do anything, but it is a warm-up for the next video, where we're going to learn how to do something more complex, like testing SQLi for every parameter we see in the proxy. In this video, we have learned the different handlers that we have available to interact with the HTTP communications in MITM proxy. And then we created a script that will log all the URLs visited in the session. And finally, we learnt how to modify a request automatically with the inline script. In the next video, we're going to learn how to do something more complex, like testing for SQLi for every URL and parameter that we see. Hi, and welcome to video 4 of section 7. In the previous video, we saw how to manipulate an HTTP request using MITM proxy. In this video, we're going to learn how we can automate a test case for SQL injection in MITM proxy, creating an inline script that we will use the request handler and some of the things we learned in the previous sections. In this video, we're going to start defining the objective we want to achieve with the inline script. Then, we're going to work on the script, and finally, we're going to test the SQL injection script we created against our web application. The objective of this video is to create an inline script for MITM proxy that will allow us to test for SQL injection in every URL that has a parameter. So the process we need to do is, for every URL that has parameters, we need to replace each parameter value by fuzz, while conserving the rest of the parameters' values, instead of replacing all the values by fuzz at once. Then we replace fuzz string in each URL by each value in the injections array. We then execute the request and match the results content with the MySQL errors in the errors array. Let's see the code. Let's go to the editor and open the file mitm-3.py. We have a few new imports. Copy from deep copy. We need this to copy objects. And URL parse, that will help us to parse the URLs. Then we have the request handler function, which whenever there is a query string, it will call the injector function. The injector function has the arrays of errors and the array of injections, similar to the ones we used in the SQLi scripts. Then we open a file to log the results, and then we use URL parse to get the query string. Then we need to split it by ampersand and obtain the length as to how many parameters we have. Once we know the length, we do a while loop. For each iteration, we're going to do a deep copy of the object query in order to preserve the original and work in a new copy. We then replace the value of the parameter qlen-1 by the string fuzz. and in URL to test, we rebuild the URL. Then we cycle through injections and replace fuzz by the injection string. Finally, we check the result content with the content in the errors array. If we have a match, we write the logs. And that's it. We have basic SQL injection capability included in MITM proxy. Let's go to the terminal. Run mitm-3.py. Then browse around in the application and finally go to www.scruffybank.com/users.php. We know that this page is vulnerable to SQLi from previous exercises. Enter some value, and that should be enough for this demo. Close MITM proxy and check the log. SQL injection_results.txt file in the editor. Great, we can see which URL is vulnerable to SQLi, and we can see the parameter with the injection that generated the error. From this point, you can continue by using the SQL injector script we created before. Now you have the basis to build your own script to cover your needs and test custom scenarios. This is the last video of the course as such. We have seen how MITM proxy works and learnt how to create inline scripts to extend the proxy and manipulate the communications. We have learnt to add a vulnerability scanner function to the HTTP proxy to assist us during web application penetration tests. In the next video, we're going to wrap up the course and provide some guidance on where to go next in your journey with Python and security testing. Hi, and welcome to the last video. This is the final video of the course. Congratulations for successfully reaching the finale. In this video, we're going to wrap up the course, propose further activities to put into practice what you learned, and finally, provide some resources to keep on learning and expanding your Python skills for penetration testing. During this course, we learnt about web application security testing. What is the methodology used by professionals when reviewing the security of a website? We learnt how to interact with a web application using Python and requests library. Once we learned the basics, we moved on to focus on how to automate the main activities of each of the methodology phases. For Reconnaissance, we developed a web crawler using Scrapy. This tool allows us to crawl recursively a website and extract interesting information. For the mapping phase, we created a brute forcing tool that will help us identify resources in a web application. Next, for the vulnerability and exploitation phase, we created a password bruteforcer in order to identify weak passwords to help us improve the password policy. This tool supported different authentication schemas, and then we learnt about SQL injection, one of the most common and dangerous vulnerabilities, and we learnt how to create a tool to detect and exploit this vulnerability. Finally, we learnt about HTTP proxies, and we created one HTTP proxy that lets us monitor and manipulate all HTTP requests and responses. And we also added the SQL injection detection capability to the proxy to check for this issue in all URLs that have a parameter in it. The course content was designed to give you a basic understanding of the web application security testing process, how Python can be used to automate many of the tasks that a penetration tester usually needs to perform, providing you the basic knowledge and skills that will help you in the future to create your own custom tools. If you are starting your journey as a pen tester, this will give you a solid base on how to build your custom tools for every situation, and will let you modify and extend existing tools. If you are already a pen tester, you have acquired a highly valuable skill that will help you stand out from other pen testers. And if you were a developer, now you have a new skill set on how to test web applications and how to automate security tests to identify issues before shipping your product. Now that you have the basics, you can continue your journey improving your skills and putting them into practice. In order to do so, I recommend the following resources. OWASP, WebGoat. This is a training course provided in the form of a VM. This training focuses on the OWASP top 10 vulnerabilities. Pentester Lab. Pentester Lab provides vulnerable applications that can be used to test and understand vulnerabilities. Also, you can test your skills in other vulnerable apps, like the ones you can find in the project OWASP WADP, a collection of vulnerable apps to provide environments close to reality. And this is it. We are on the last slide of this course. Thank you very much for choosing this course, and I hope you have enjoyed and learned about web application testing with Python.